This first beam is an over-reinforced concrete beam loaded in 3-point bending. The reinforcement consists of 3 20mm diameter high-yield steel bars in the tension zone and 2 8mm diameter bars in the compression zone. 8mm diameter steel stirrups are provided along the length of the beam to prevent brittle shear failure. The beam is loaded in 3-point bending. A single point load is applied at the centre of the beam, and 2 reaction points are supplied, one at each end of the beam. The supports consist of pivots which allow for rotation and translation at the ends of the beam. As loading proceeds, cracks in the concrete are searched for and marked clearly on the beam. As can be seen from the load deflection graph, initial behaviour occurring under service loading is approximately elastic. As the beam approaches failure, crushing of the concrete occurs, leading to some limited ductility as shown by the plateauing of the load deflection plot. However, the steel reinforcement remains elastic and does not contribute to the ductile behaviour. Spalling of the concrete leads to failure of the beam. This is an undesirable mode of failure since failure occurs in a brittle manner without significant warning rather than in a ductile manner. Ductility at the ultimate limit state is desirable since it gives plenty of warning that elements are being overstressed and also aids redistribution of moments in continuous structures. Therefore, beams should be designed so that the ductile steel yields before crushing failure of the concrete occurs. Let's look again at the complete behaviour of the beam up to failure.